of second sequence. Second sequence we have 5, 10, 15, 20 which are multiples of 5. The reciprocals of those terms are 1 by 5, 1 by 10, 1 by 15, 1 by 20, so on. And this is a beautiful sequence which is called as Fibonacci sequence. Let us consider first two terms are 1, 1 and the third term is obtained by sum of first two terms, that is 1 plus 1 is 2 and 1 plus 2 is 3 and 2 plus 3 is 5 and 3 plus 5 is 8. What is next term? Can we guess? Yes, the next term is 5 plus 8 is 13. Okay, so like this we can see some different patterns in mathematics, okay, which are arrangement of numbers which follow some rule. Okay, and in these arrangement of numbers, some of the sequences are starting from a number and move ahead. Okay, so these type of sequences are called as progressions. So let us learn what is a progression. A progression is an arrangement of numbers starting from a number and moving ahead according to a rule. Okay, next there are different types of progressions in mathematics. So first one is arithmetic progression, and second one is geometric progression, which is denoted like GP. Next, third one is harmonic progression, indicated as HP. So these are mainly we learn arithmetic progression, geometric progression, harmonic progression. We have many progressions. In arithmetic progression, we will get each term by adding a fixed number to preceding number except the first term. So that is arithmetic progression. Whereas geometric progression, so each term will be obtained by multiplying a fixed non-zero number to the preceding number. Okay, similarly here the terms of harmonic progressions are reciprocals of the terms of the arithmetic progression. In our class 10th, the harmonic progressions were not included. We are going to learn arithmetic progression and a part of geometric progression. Let us learn arithmetic progression in detail. First we will see some examples. Here we have 1, 3, 5, 7. Students, observe, if we add each term with 2, then we will get next term. So here the starting term except the first term. So here the starting term is 1. If we add 2, then we will get 3. Then 3 plus 2 is 5. 5 plus 2 is 7. What is next number? 7 plus 2 is 9. Like that we can guess. Next, in this one, the each term is added by 5. In this one, if we add a fixed number 1, then we will get next terms. In this sequence, what is the fixed number? Can you guess? Yes, the fixed number is 0. 8 plus 0 is 8. 8 plus 0 is 8. 8 plus 0 is 8. And in the last one, the fixed number, that is minus 10. 10 plus minus 10 is 0. 0 plus minus 10 is minus 10. Minus 10 plus minus 10 is minus 20, like that. So these are the sequences which are following some particular rule. That is, we are getting each term by adding a fixed number to preceding term except the first term. So these type of progressions are called as arithmetic progressions. Okay, let us see. The arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So that is called as arithmetic progression. Okay, in arithmetic progression, each term, we are getting each term by adding a fixed number to the preceding number, right? So that fixed number is called as common difference. That fixed number is called as common difference. So, and that is denoted with the D. In an arithmetic progression, the difference between any two consecutive numbers, is constant. That constant is called as common difference, which is denoted by D. Now let us see the series of arithmetic progression. So the terms of the arithmetic progressions are of the form A1, A2, A3, so on An. In this A1 is called as first term, and whereas A2 is called as second term, similarly A3 is called as third term, and so on. The last term An is called as last term or nth term, or we can say that general term also. So if we subtract consecutive terms, if we find the difference between two consecutive terms, those are a2 minus a1 and a3 minus a2, so on an minus 1. So all these differences are same, and that common difference is denoted by d, and this d is called as common difference of arithmetic progression. Just now we have seen a1, a2, a3, so on an are terms of arithmetic progression, right? So now we are going to find what is nth term of arithmetic progression. Okay, let us see. So what is first term? That is a1, which is denoted with a. So we have to add a fixed number, right? So the fixed number is called as common difference, that is d. So here I am adding d, then I will get second term. This is the second term, which is denoted with a2, adding d to the first term, that is a1 plus d. a1 is nothing but a plus d. So here we have 2, in the coefficient of d is 1. So that can be written as a plus 2 minus 1 into d. Why? Means that it was reduced 1 unit. Next, what is third term? The third term is adding d to the second term, that means a plus d, that is a plus 2d. So here a3 is equal to a plus 2d, right? Here we have 3, here we have 2. That means it was reduced by 1 unit. So that means which can be written as a plus 3 minus 1 into d. So students, can you guess what is next term? Here we have a2 is equal to a plus d, a3 is equal to a plus 2d. Next, what is a4? Yes, a4 is a plus 3d. What is a5? a5 is a plus 4d. What is a6? a plus 5d. So like that, what is a99? So a99 is what? A plus 98d. Just simple logic, we have to reduce one number, that's it. So a plus 98d can be written as a plus 99 minus 1 into d. Now can you guess what is the nth term of AP? Simple. So that is an is equal to a plus n minus 1 into d. So here we have n, here we have to reduce one number. So an is equal to a plus n minus 1 into d. Remember, this n is a natural number. So n should be 1, 2, 3, 4. Why? Means these are counting numbers, first term, second term, third term, fourth term. So we cannot say minus 1 term, minus 2 term like that. That's why n should be a natural number, remember it. Okay. So what are the terms of, this is the nth term, right? an is equal to a plus n minus 1 into d. In this, what is a? A is first term. Next, what is d? D is the common difference. And what is an? It is also called as nth term or general term. It is sometimes denoted by L, and also rare times we denoted with B also. And next, n. What is n? Number of terms in the given progression. Students, in this formula, the formula is an is equal to a plus n minus 1 into d, right? So in this formula we have how many terms? 4 terms, a, n, d, an. So in 4 terms, in some questions they will give 3 among 4. We have to estimate the fourth one. So by using this formula, nth term formula, we can find any term. That means if they will give a, d, n, then we can find easily an value by using this formula. Okay, so that is the importance of this nth term formula. And let us see some general form also. So what is the general form of AP? That is a plus d, a plus 2d, a plus 3d, so on. That is general form of AP. Here I am giving one more point also, that is what is finite AP, what is infinite AP. So finite AP means the word itself contains the meaning, that is the series contains only finite number of terms. That means if we have 1, 2, 3, 4 up to 100, that is called as finite AP. Okay. If we have infinite number of that means natural number set. Natural number set is comes under infinite AP, 1, 2, 3, 4, so on, right? So that is comes under infinite AP. So this is the general form, a plus d, a plus 2d, a plus 3d, so on. This is the general form. What is the relation between a, b, c? If a, b, c are in AP, then what is the common difference? The second term minus first term, that is b minus a, is equal to third term minus second term, that is c minus b. So rearrange the terms, then we will get minus b bring to left hand side and minus a bring to right hand side. We will get b plus b is equal to a plus c. So then 2b is equal to a plus c, 2 bring to right hand side, then it becomes b is equal to a plus c by 2. So this is the, if a, b, c are in AP, then b is equal to a plus c by 2 or 2b is equal to a plus c. So this is the relation, this is the important relation. Based on this relation we may get some problems in examinations. Okay. Now we have knowledge on nth term, right? So we will solve some problems based on that formula, nth term of AP formula. Okay. So this is the first problem. Is root 2, root 8, root 18, root 32 forms an AP. If it forms an AP, then find the value of D and the value of A5. A5 is nothing but fifth term. Okay. So students, when we have one problem, we have to read the problem carefully and try to write the given data and try to write the related formula, and we can solve the problem in easily. Okay. So here what are given? Root 2, root 8, root 18, root 32 are terms. So in that one, first term is root 2, which is denoted with A1. Okay. So what is next term? That is root 8. 8 can be written as 2 square into 2. 2 into 2 into 2 is 8. 2 square into 2. What is the square root of 2 square? That is 2, and into root 2. So the value of root 8 is 2 root 2. Next, what is the value of root 18? Root 18 can be written as root 9 into 2. 9 can be written as 3 square into 2. So what is the square root of 3 square? 3 into square root of 2. Okay. Now find the difference between consecutive terms. So what is A2 minus A1? A2 minus A1 is 2 root 2 minus root 2, that is root 2. 2 root 2 minus root 2 is root 2. Next, what is the difference between A3 and A2? So that is A3 minus A2 is equal to 3 root 2 minus 2 root 2, which is equal to root 2. Here the common difference A2 minus A1 and A3 minus A2 both are same. So therefore we can say that the given terms forms an AP. The given terms forms an AP, and we need to find, what is our question? We need to find D, common difference D, and fifth term. So just now we have seen how to find the common difference. The common difference is root 2, and fifth term. How can we find fifth term? Like this. So fifth term formula, A5 is equal to A plus 4D. By using an is equal to a plus n minus 1 into d formula, we will get a5 is equal to a plus 4d. We got a value, that is first term root 2, substitute here, plus 4 into d value is root 2. Now what is the value of root 2 plus 4 root 2? The sum of root 2 and 4 root 2 is 5 root 2. So fifth term is 5 root 2. Okay. So like this we can find any number of term. That means we can find 100th term also. Okay. Right. Next, second problem. This is the second problem. In an AP, if d is equal to minus 3, n is equal to 18, and nth term also given, that is minus 5, then our aim is to find the value of a. In the previous problem we have estimated common difference. In this problem, common difference, number of terms, and nth term was provided. So we should find the value of a. So by using same formula we can find what are the given values. The given values are d is equal to minus 3, n is equal to 18, and an is equal to minus 5. That is nothing but, what is n here? 18. That is a18 is equal to minus 5, right? So from the formula an is equal to a plus n minus 1 into d, what is a18? Is a18 is a plus 17d. So a plus 17d is equal to minus 5. So here we have d value, substitute in this equation, then we will get a plus 17 into minus 3, which is equal to minus 5. What is 17 into minus 3? Minus 51. So a minus 51 is equal to minus 5. Bring minus 51 to right hand side, we will get a is equal to minus 5 plus 51. So 51 minus 5 is 46. So therefore the value of a is 46. So by using nth term formula we can find the value of a. Next, see one more example. Here one interesting problem, that is the 17th term of AP, the 17th term of AP exceeds its 10th term by 7, then find the common difference. Okay, so write the condition. What is the given data? 17th term is denoted with A17, which exceeds 10th term by 7. So that can be written as A17 is equal to A10 plus 7. 17th term exceeds the 10th term by 7, means we have to increase 10th term by 7, then we will get 17th term. That is the condition. Okay. Now as we know about the term A17, what is A17? That is A plus 16D. What is A10? A plus 9D. Substitute here. A17 is A plus 16D, A10 is A plus 9D plus 7. Here both sides we have A, right? We can cancel it. Okay, A cancel. Now bring 9D to left hand side, we will get 16D minus 9D is equal to 7. 16D minus 9D is 7D, which is equal to 7. 7 gets cancelled. So what is the value of D? So D is equal to 7 by 7, right? So 7 by 7 cancel, we will get D is equal to 1. So this is one more problem. Okay, let us see one more example. Which term of the AP? 3, 8, 13, 18, so on is 78. So 3, 8, 13, 18 is AP. It is given, it is an AP. So in this sequence, in this progression, somewhere we will get the number 78. We may or may not get, so that we have to check. That means, so let us consider the given number 78 as a n, then solve by using nth term formula. We will get which term is 78. Okay, right. So in this given AP, what is A? This is the first term, right? First term is A. Okay, A is equal to 3. And what is the common difference? Second term minus first term, that is 8 minus 3, which is equal to 5, or 13 minus 8, also 5. So that is called as common difference. And let us assume that an is equal to 78. Now we have to find which term is 78. So as we know the formula, an formula, what is the formula? That is a plus n minus 1 into d. An is equal to 78, right? So a plus n minus 1 into d is equal to 78. Now substitute the values. What is the value of a? 3 plus n minus 1. We don't know the value of n. We should find the value of n. So the value of d is 5. Replace it, is equal to 78. Now bring this 3 to right hand side. Then we will get n minus 1 into 5 is equal to 78 minus 3. 78 minus 3 is nothing but 75. So bring this 5 to denominator. We will get n minus 1 is equal to 75 by 5. What is the value of 75 by 5? That is 15. So as n minus 1 is equal to 15, bring minus 1 to right hand side. You will get n is equal to 15 plus 1. So then n is equal to 16. Okay. So 16th term is 78. So in the given question, the 16th term is 78. Sometimes we may get n value as negative or n value as 0. So in that case, the 78 may not be exist. So now I am giving one task to you. So which term of the AP 3, 8, 13, 18, so on is 77? Take an is equal to 77 and solve it. You will get a fraction or negative number or like that. So n should not be a fraction. Okay, n should be a natural number. Okay, then only we can say that here 16th term is 78, right? Like that we can say. So if we take 77, the 77 is not in this AP. That's why we make it n as rational number. One more beautiful problem, that is find the 31st term of an AP whose 11th term is 38 and the 16th term is 73. Okay, it is an interesting question. Here 11th term given and 16th term also provided. 11th term, 16th term. By using those two terms, we should find 31st term. Okay. So first write given data. What is given? 11th term is 38. That means A11 is equal to 38 and 16th term A16 is equal to 73. Okay. Now our aim is to find the value of 31. How can we find? So first solve these two. First by using these two conditions and solving, we will get. So what is the formula actually? A31 is equal to A plus 30D, right? A31 formula is A plus 30D. So for that, to find the value of A31, we should find A and D by using two given conditions. Okay, let us solve. A11 is equal to 38. What is A11? A11 is nothing but A plus 10D from nth term formula, that is A plus 10D is equal to 38. From this I am writing A as 38 minus 10D. So bring 10D to right hand side, we will get A is equal to 38 minus 10D, which is relation 1. Okay. Next, second condition, that is 16th term is 73, A16 is equal to 73, A16 is nothing but A plus 15D, which is equal to 73. This is the relation 2. So solve these two relations. Okay. Otherwise maybe A plus 10D is equal to 38 also equation number 1. Then these are the two linear equations in two variables. Okay, solve those two linear equations in two variables, you will get A and D. So this is another method, this is a substitution method. Okay, so A is equal to 38 minus 10D, substitute this value, A value in 2, substitute 1 in 2, as these are two are linear equations, we can solve by elimination method or substitution method, like that. Okay, so after substituting, replace here A, replace in the relation 2 A with 38 minus 10D. So then this relation will modify like this, 38 minus 10D plus 15D is equal to 73. Now 15D minus 10D, these are like terms, then that is 5D. Now at the same time I am sending 38 to right hand side, then it becomes 73 minus 38. Now 5D is equal to 35, 73 minus 38, how much? 35. Now divide 35 with 5, D is equal to 35 by 5. What is 35 by 5? 7. So now we got D value is 7. Now substitute this D value in the relation 1 or 2. Okay. So what is the relation 1? That is A is equal to 38 minus 10D is the relation 1. So as D value is 7, substitute here, 38 minus 10 into 7, 10 into 7, 70. So 38 minus 70, that is minus 32. So the value of A is minus 32. So here by using first two conditions, that is from 11th one and 16th term, from those two relations we got A value as minus 32 and D value as 7. Now we can find the value of A31, that is 31st term value we can find easily. So A31 is equal to A plus 30D, as we got A value and D value, substitute here. So A is equal to minus 32 plus 30 into D value is 7. So minus 32 plus 7 into 30, 210, 210 minus 32 is 178. So the 31st term is 178. So these type of problems are very important. Okay. So students, solve these type of problems which were given in your textbook. Next problem, very interesting problem in your competitive examinations also. Okay, here it is given that how many 3-digit numbers are divisible by 7. What is the smallest 3-digit number? Is 100. What is the largest 3-digit number? 999. So in these 3-digit numbers, only some numbers only divisible by 7. We have to find how many 3-digit numbers are divisible by 7. Okay, so by dividing each term with 7, whether it is divisible by 7 or not, it is somewhat difficult task. We can count, but somewhat difficult. Okay, but by using arithmetic progression concept, we can find number of 3-digit terms which are divisible by 7 or which are divisible by 3 or which are divisible by any given number. We can solve in easy way. Okay, so for that, first, what is the smallest 3-digit number? 100. Okay, so divide with 7, we will get remainder 2. That means we should add 5 more. That means 14 into 7 is 98. 14 sevens are 98, right? What is 15 sevens? 105. So after 98, the number which is 105, 105 is divisible by 7. Okay, 100, 101, 102, 103, 104, which are not divisible by 7. The starting 3-digit number which is divisible by 7 is 105. So similarly, we can find largest 3-digit number which is divisible by 7. So in this way we can find. So largest 3-digit number is 999, divide with 7. After the simple division calculation, the remainder is 5. So 999 minus 5, 999 minus 5 is 994. So the greatest 3-digit number which is divisible by 7 is 994. Okay, smallest number is 105 and largest number is 994. By adding 7 to each term, we will get the progression. So the first term is 105. If we add 7, then we will get 112, then 119, so on 994. So these are the 3-digit numbers which are divisible by 7. Now our aim is to find how many 3-digit numbers are there which are divisible by 7. So clearly we can solve here. What is the first term? 105, right? And what is the common difference? As it is divisible by 7, the common difference is 7. Okay. Now let us assume that the last term is an is equal to 994. Okay. So by using the formula an is equal to a plus n minus 1 into d, we can find the value of n. So a plus n minus 1 into d is 994. Here a value is 105 and d value is 7, and solving by simple computations like n minus 1 into 7 is equal, bring 105 to right hand side, we will get 994 minus 105. So what is 994 minus 105? That is n minus 1 into 7 is equal to 889. 994 minus 105 is 889. Now bring here 7 is multiplying to n minus 1. Now bring to right hand side, it will divide. So n minus 1 is equal to 889 by 7. 7 ones 7. Here 18 is remaining. 7 twos 14. Here 4 is remaining. 49. 7 sevens are 49. So n minus 1 is equal to 127. Then n is equal to 127 plus 1. N is equal to 128. So by using arithmetic progression, simply we have estimated there are 128 3-digit numbers. There are 128 3-digit numbers which are divisible by 7. So in the same way we can find how many 4-digit numbers are divisible by 9, like that we can find. Okay, right. So till now we have solved beautiful and interesting problems based on nth term formula. Okay, so what we have learned here till now, that in this lesson we have learned what is an arithmetic progression and what is nth term of an arithmetic progression. So these two concepts, and we have also solved beautiful problems on this concept, nth term concept. Okay, students, now it is time to solve the problems related to nth term of arithmetic progressions. So these are the problems for you. First one, find the 10th term from the end of the AP 8, 10, 12, so on 126. How many multiples of 4 lies between 10 and 250? Next, third question is, which term of the AP will be 120 more than its 21st term? Interesting problem, that is, if 5 times the 5th term of an AP is equal to 8 times its 8th term, show that its 13th term is 0. Okay, so these are some problems based on nth term concepts. Now students, for better understanding of the concepts, solve the worksheets. Please visit the official website of SERT for worksheets. Okay, so students, with a beautiful lesson we will meet in next class. Okay, thank you.